A modern industrial workplace is a complex environment of dormant chemical reactions waiting to be triggered. Every pallet, wire, and drum represents a contained hazard. Managing these hazards requires structured knowledge. As you can see highlighted on this instructor card, formalized fire safety training, led by certified experts like Pawan Singh, equips a team to recognize these risks before they escalate. This 3D fire triangle breaks down what an emergency actually looks like at the molecular level. A fire is a precise chemical reaction called combustion, and it requires three specific elements to survive: heat, fuel, and oxygen. Looking at these first three hazard icons, short circuits, improperly stored flammables, and hot work sparks serve as physical triggers. But sparks rarely start a crisis alone. As the remaining icons show, human behavior, like negligence or combustible clutter, provides the ready fuel. These overlays define the defense against those behaviors. Active, daily habits like good housekeeping physically remove the fuel loads, while vigilant, routine inspections catch equipment faults long before they spark. Ignore these daily routines, and you supply the exact ingredients needed to complete the chemical loop, turning a functional workspace into an active threat. Once ignition occurs, the priority shifts immediately from prevention to chemistry. To stop a fire, you have to mathematically dismantle the reaction. This classification grid shows how fires are categorized strictly by their fuel source. The spectrum ranges from Class A solid combustibles, like wood and paper, up through combustible metals, and finishes at Class F or K, representing high-temperature cooking oils. These top rows show primary tactics, attacking heat with water-based cooling, or cutting off oxygen, known as smothering. The bottom rows show removing fuel through starvation, or using dry powders to inhibit the chemical combustion process itself, stopping the chain reaction. Attempting to suppress a fire without first identifying its fuel class can escalate the emergency. Throwing water on burning oil or a live electrical panel risks an immediate, fatal explosion. This rigid classification is exactly why fire extinguishers act as highly specialized chemical delivery systems, rather than universal tools. Red water and cream foam units handle Class A and B fires, with an explicit warning against using water on electrical hazards. The remaining colors are specialized: black CO2 for electrical, blue dry powder for multi-purpose threats, and yellow wet chemical for cooking oils. Once the right tool is in your hands, you execute a strict operational procedure known as the pass method. The first two steps require pulling the pin to break the seal and aiming the nozzle directly at the base of the fire. Finally, squeeze the handle fully and sweep the nozzle from side to side for complete coverage. Relying on the ingrained muscle memory of the pass method strips away the need to think under extreme pressure, maximizing the chemical effectiveness of the extinguisher during the critical first seconds. There is a defined limit to these defensive measures. Once a fire grows beyond a small, easily containable footprint, the sole objective shifts from property protection to personal survival. This flowchart outlines the mandatory sequence for an unmanageable crisis. You immediately raise the alarm, communicate with the safety team, evaluate the danger level, and initiate evacuation. Looking at the green do column, priorities are clear: raise the alarm, evacuate safely, and only select an extinguisher if trained. Conversely, the red don't column highlights critical failures. Panicking, using elevators, or deploying water against explosive fuel rapidly compounds the danger. As you move to the assembly point, strict environmental rules apply. These instruction cards emphasize following illuminated green exit signs and, crucially, crawling low to the ground to stay safely underneath the rising layer of toxic heat and smoke. This final card solidifies the core lesson: your reaction speed and knowledge dictate the outcome. Booking further training and certification through your local instructor ensures you build that vital reaction speed. True safety relies on committing to a continuous routine. By maintaining equipment, understanding the chemistry of combustion, and mastering evacuation protocols, a vulnerable workspace becomes a highly protected environment.